us on applications of IoT and hardware, and will also have hands-on session on application design using workstation. So without taking much time, I request Dr. Suresh Babu sir to continue with the session. Sir?
Yeah, thank you, madam.
Over to you, sir.
Thank you. Now, may I know how many people out of 21 members have already installed the two software which I have given yesterday? Please try to respond to me so that whether it is possible to go for hands-on approach, or let me explain the concept from my side. Out of 21 members, so how many people are already installed?
Sir, participants are still joining, so you can start with the hands-on session only.
Now, no one is installed here in 20 members, madam? Yesterday I told it the softwares, whether they have installed or not. That's information I want from participants.
Yes, sir. Yes, participants, whether all of you have installed the software. Yes, sir.
Yeah, one person is already responded. Okay, without wasting much time here, let's we go. Why we are going for now? This biggest challenge, especially when we want to teach IoT. Yeah, it requires because if you want to work on the IoT devices, because you are going to run two operating systems there. Two operating systems which are going to work. One is Kontiki, is an embedded operating system. The other one is Ubuntu, which is working on top of the Kontiki. Now, why I'm telling, especially why we want to use, because if you want to teach IoT, the major problem is you need to require the hardware. Now, how many people are ready to buy the hardware is the biggest challenge, especially when it comes to the student side. So theoretically, we will not give the appropriate solution to the IoT. Now, there are some certain simulation models were there. Where we can only see the basic behavior or the behavior of the system, but we don't know what is the actual real-time system. Now we want the combination of both the simulation-based as well as the real-time instance, so that once we know the real the behavior of the system, then we can take real hardware where we can embed the code into the hardware and still it can work it out. So therefore, there's a Kontiki is a one type of an embedded operating system which is going to work on top of Ubuntu. There is a Kontiki next generation, which is a little bit higher version, which is working on that. Interested, especially the people who are doing research, you can start working on, especially if you are doing on IoT, you can start working on that. That we are going to see in today's session. Right, before I proceed to the IoT concepts which you are going to see, let me start with the Kontiki and the Puja, which I told on the. Now we'll try to see the Kontiki OS introduction part. They have something. There are so many operating systems were there. If you see, Tiny OS is there. Real-time operating system were there. There are so many operating systems were there which are working on embedded devices or embedded system. Now, the Kontiki is one of the popular one which has some unique features, which have some built-in networking features which are there in the in this OS, so that we need not to worry about the networking features. Only we can concentrate on the performance of the system can be easily done using Kontiki OS that we are going to see in today's session. Let me start this OS operating system. So there are certain important features were there in Contigi, because one of the important feature it has is open source, because we need not to buy anything. It's an open source operating system which is going to be worked for, especially for the Internet of Things, which we have. Especially if you want to work on Internet of Things with respect to the hardware, you can have it. And see, it runs on network. That's because when we talk about IoT, the things are going to be connected to the internet, because the internet is also we can call them as a network of things, which we can call them as. So networked embedded system, and then wireless sensor devices can be connected to that. So therefore, we can say the Contigi is designed for microcontrollers with a small amount of memory. As we know that it has a limited physical size, limited memory, all these things. So we can say that some of the important characteristics, it has low cost, low power microcontrollers which are connected to the internet automatically. Right? When this device is there, when the device is connected when the device is connected to various sensors, and this device has a built-in internet module, so that directly we can connect it to the internet. That in the inherent feature is there in Contigi operating system itself. Now this is a Contigi operating system where we can work it out. We are not see, this is a hardware which we have a radio, physical radio. We have a CPU. We can connect to the various sensors. Oscillators can be connected, or other devices can be connected to that. And this core. See, the major important factor that we are interested with is micro IP, which is going to be supported, right? And then we can create a lot of applications with the node map, with the sensor data manager, code updater will be there, sensor configurator will be there, network configurator will be there, which are the part of the network operating system, Contigi operating system which we have. So a typical Contigi, it is required. I think someone has told 2 GB, because 2 operating systems you are going to work on your virtual machine. So usually for Contigi operating system, what is required minimum is 2 kilobytes of RAM, and 40 kilobytes of ROM will be is usually used, right? And it provides what? IP communication. As you already know that the IP is one of the important for providing the communication to the end devices. It supports both IPv4 as well as IPv6. Okay, that's an important point we have. And it has IPv6 stack, protocol stack, which I told you. Like, for example, if you take IoT protocol stack, we can have a COAP, it's an application protocol. UDP is a transport protocol. IP is an internet layer protocol. Then we can use either 802.15, 802.15.4 physical and the MAC layer which you're going to have. So this we call them as what? A stack, a protocol stack, which is going to be enabled in the Internet of Things.
Sir?
Yes.
Sir, are you presenting the screen?
Yeah, it's not visible.
Sir, no, sir, it's not visible.
Then I covered almost 4 or 5 slides. I think. Oh. Now it is okay? It's visible?
Yes, sir.
Right. Let me explain once again. This is a very important thing we have. Because if you observe carefully here, someone should mute and tell me no, because your last 5 to 10 minutes were explained. Once again, because it's an open source operating system, especially designed for Internet of Things, which I already told you, and it runs on a network embedded system with wireless sensor nodes, which you've been having. And Contiki is designed for a microcontroller with a small amount of memory. As you know that, because it's embedded, if you take Arduino, it have a microcontroller and have some memory model will be there, and then we have a sensor model will be there, power management model will be there, Wi-Fi model will be there. So definitely the Contiki is designed for microcontroller with a limited amount of memory. So especially it is going to connect the low cost, low power microcontrollers which are going to be connected to the internet we have. Okay. Now this is a little bit configuration which you are going to have it, because if you take any hardware which is which we can connect it, we can have a physical radio which we'll see, and we have a CPU, we have the sensors, oscillators, and any other mechanisms we can use it. Right? You have this, if this is there, micro IP, which is because we are working on tiny devices, we require micro IP where it should be lightweighted. We cannot have a highly loaded IP address we can store it. So it should have a micro IP, so that it is a lightweighted protocol which we are going to use it. And then in node management, we can create the sensor data manager, code updater, then configurator will be there, and network configurator will be there, which you are going to connect it to the Contiki OS. Now, what are the configuration requirements, especially for the Contiki? If you want to install, we require 2 kilobytes of RAM and 40 kilobytes of ROM, which is required. And then, because we are interested to provide, to have a communication of various sensor devices to the internet. Now, we require some IP communication. IP communication, it supports both IPv4 as well as IPv6 at the same time. So that's a point we need to aware with IPv6 stack, in the sense, because if you are working on IoT, the IoT protocol stack is what? COAT, we have UDP, we have IPv6 or IPv6 protocol, and then network technologies like 802.15.4 MAC and 802.15.4 physical. So this is something like a protocol stack which you are going to use it, right, for with the power efficient radio mechanism such as Contiki MAC, which you are going to use it. Okay. And definitely it is going to operate on battery operated devices to participate with IPv6 network. You will try to see how we are going to do all these things. Okay. And yesterday we have seen this mechanism. Contiki supports a 6-LoWPAN. 6-LoWPAN stands for IPv6 low power personal area network. IPv6 low power personal area network header compression, and COAP. COAP stands for what? Constraint Application Protocol. Constraint Application Protocol, which is an application layer protocol, is similar like HTTP protocol. Okay. And then we are going to see, compared to the other things, because Contiki applications usually written in standard C, and they're very fast and easy, we can do it. And then we are going to have one more simulator called Puja. You're going to have one more simulator called Puja. Puja is a simulator, or we can call them as an emulator, which is going to work on Contiki networks that can burn directly into the hardware once you have been simulated. That's a beauty we can have, especially with the Contiki OS, which you're going to see. Okay. Now, we will try to see what is this Contiki, which is a network emulator we can have, because we know that we want to know, right, one system should behave like the other system, right? Suppose, for example, if I go to the HOD, I'll behave differently. When I'm interacting with the students, my behavior is different. So, a same person, two behaviors we are going to have. Now, we are going to emulate it, right? We are going to emulate. That's why an emulator is in hardware and software that is going to enable one computer system, we call them as a host, to behave like another system, like a guest node which we can be created. That's the emulator which you could have. So Puja, now if you are installing your Contiki on your system, now your laptop will work like a Z1 mode. Can anyone tell me what is mean by mode? Can anyone tell me what is by mode? What do you mean by mode? See, I think you are the faculty members, isn't it? And you are taking online classes. If the students are not responding, then I think you will feel a lot of sad, isn't it? Because to whom you are saying. I'm not saying to the fans or switches or to the lights. I'm saying to the faculty members itself. You please to respond if you know or don't know. At least a little bit interaction is required to create a lot of awareness among you people. Please try to respond so that it will create a lot of interest especially because see you are taking online classes and no student is responding and you will not get interest, isn't it? Same situation for me also usually. So please I request the participants, please try to respond so that you cannot sit continuously 1.5 or 2 hours just by listening. Only by interaction only you can have it. Okay, sorry, don't mind to have a little bit this. Right, thank you. Now see, right, a few members have been responded. That's a good thing. I think if you are responding, it's a good compared to the other people. People are responding. Yesterday also, I'm very pleased. I think people are involving here. Now, a mode is right. It's a sensor node. A mode is a sensor node which has the capability of processing, right, transforming the data, as well as storing some information, which you could call them as a mode. It has some little bit capabilities to perform some operations. So for that, we call them as a mode, right? We call them as a Z1 mode. Now this is the Z1 mode we can have. Now this mode has some. We have microcontroller will be there, right? Embedded antenna will be there here, which you're going to see. Which is embedded antenna will be there, and then we have an accelerometer will be there, plus temperature sensors will be there, two temperature and micro USB is there, and then sensor ports which we are going to be connected. This is a mode which has some processing, which are going to be used for processing purpose, storing and transmitting the data. Right? Same like Arduino kit, Arduino and Raspberry Pi kit is going to work in such a way. Right now, we'll try to see. I think now I want to ask how many people already installed. I think now few members have been joined. 33 members have been joined. How many people have installed so that we can do hands-on? I'll show you, and you can practice there itself. How many people have did that?
How many participants have installed the software that was told yesterday?
Okay, I think only one person has installed one person. But anyway, no problem. What about the others? Okay. Now, at least I'll show on my system, and you can do it on your own system, which you can have it. I'll open one more system for you. Let me start with this quantity which you're going to have, and then we'll go to start how we're going to work on the quantity as well as the kucha. Okay. Okay, let me start this with Kontiki and Kuja. We are going to start with this one. Can you see my screen?
Yes, sir.
Okay. Now, you see, as I already told you, we required a VMware workstation player. Just I'm going to double click that VM workstation player. It will take some time to open it. Then, as I already told you, it requires those 2 GB of the data which you're going to have it. Now, what we are going to see, we are going to take instant quantity, right? We are going to take an instant quantity, select that instant quantity, and then play virtual machine. Let me start. Right now, what we are going to do, we are entering into the instant quantity. The password for this one is user. The password for quantity, instant quantity is user. Once we click on the user, then you will get this screen. Right, you will get this screen, and then I told you, no, we have a Kucha. Kucha is an emulator. Right? Are you following now, all of you? This is a Kucha is an emulator where you can work it out on later case. Right? Now, what we are doing now, if you want to run on the any simulation on Kucha, now what I'm going to do, I'll click on the Kucha. Now, it will take some time to build. It will take some time to build Kucha. Then we got this Kucha is a network simulator. Everyone is following? It's okay. You can do at a later case also. Right. Now, what we are going to do, we are going to start with a simple hello world. Then I'll go to the little bit experiment wise. First, we go to the new simulation. We'll select the new simulation. Then we'll write a simple hello world. We'll write hello world. Hello world program. Right now, what we need to give with there are different types of wireless. We are going to choose unit disk graph medium with for the drop distance loss, which we're going to take it, and then we are going to create it. Then when we create it, we are going to get five. Then we are going to get 5 windows. These are the 5 windows we can have. Right. The first one is this one is the network window. This one is the simulation control window. This is a nodes window. We can have it. And then this one is a mode output window. And then this is the timeline window we have. So 5 windows which you are going to see. One is the network window, then simulation control window, nodes window, mode output window, and the timeline window. So these 5 windows which you are going to have. Then what is that we are going to do? Now we need to create some mode, which I told Z1 mode, for any temperature reading or all these things which you are going to take. Now we go to the modes. Anyone is doing, so that I will go a little bit low, otherwise it's okay. Okay. One faculty member is doing this. Now what we are going to do, okay. You can try it later, sir. Any this recording will be available to you. You can do it because, or you can try it slowly. I'll go. Then we go to the add modes. Then create mode type. Then we are going to have a Z1 mode. We can have a Z1 mode. We can have a Sky mode. We can create whatever the mode you want to create. So this is the Z1 mode which you're going to create. Now once we get the Z1 mode, then you'll get a dialog box with a create a mode type. Whatever mode we are going to create, we are going to create a mode type for Z1. Now we need to go for that one. I want to take my embedded C program or C program where I can have some hello world program. Then go to the examples. Go to the examples. There is a folder called hello world. There is a folder called hello world. You double click on that hello world. There is a file name called hello world.c file. Hello world.c file is there. You create. Then we need to convert that make hello world.z1 target. You need to compile. Right? You need to compile. So for compiling, it will take some time to compile. So we have created what? Hello world.z1. Hello world.z1. Right? Now once we create it, now I want to create a hello world program. Now just I'm going to create 5 nodes, 5 sensor nodes with 5 Z1 nodes which are sensing capability and create it. Now you can see these are the 5 nodes which have been created here. This is node 1, node 2, 3, 4, and 5. 5 nodes which have been created. Right? Now we need to see what is the, what is that? So we are going to create IP addresses. Now currently we have not used any IP addresses, right? And we want to print the output, whatever, if we want to print any output or LED information, we can have the LED information, which you can have it, and the position, at which position it has been, the node has been placed. Once we know the proximity of that position, we can have it. And the mode type, these are the mode types which are going to color will change, and then mode attributes which you are going to have it, and then radio environment. Now this is a radio environment. If you see, this is a radio environment which you are going to see. Usually we have 3 ranges: transmission range, detection range will be there, right? And noise range, or we can have interface range which you are going to have. Okay, so these are the modes which you are going to add. These are the different modes which you are going to select. Now, once we created these modes, and then we can click the start button. This is the whole information it has been done. It is going to give. So you can see we are seeing CSMA map control will be there. Hello world process is started, and we are printing the hello world. If you see, each and every node hello world is printed. That node is going to print the hello world to you. You got it? Do you have any doubts here? You're able to follow me? Now, this is a small hello world program. Then, if you want to work on IoT devices that we are going to see now, first we'll try to see theoretically, then we'll go for how to implement it practically. I'll show you step after the step. Then what I'll do is I'll stop the screening. Then first we'll try to see. Then what I'll do is I'll create a presentation once again. I'll go here. Yeah. Now we are going to see a network called broader router simulation. My screen is visible.
Yes, sir.
Now, this is very important. You can do a number of experiments which you can do if you want to teach to the students. You can do it. Now, we are going to see a broader router simulation, which you are going to see step by step. Now, you see, now what is this? This is a little bit interesting one. We are going to have. This is the RPL network. We call them as this is a sensor node which you are going to create in the RPL network. These are the sensor nodes we can have. This is a sensor node. It can be any type of a sensor node which you are going to have, right? And then this is a broader router. This is a broader router, and this is the external network which you are going to connect it to the internet, right? So RPL network will be connected to the external network through broader router. Like suppose, for example, a person, outside person want to communicate it. Outside person want to communicate to the inside person through broader router, which you are going to have, that we are going to see. Now, the broader routers are the routers that can be found at the edge of the network. We can this broader router is also called as a fog node. Yesterday we have seen, no, it has a little bit better capability. The broader router are the router that can be found at the edge of the network. Then, what are the code we are going to use to implement this broader router concept, which we are going to see. One is broader router.c. The other one is UDP server or UDP client, because we want to communicate one from the client and server. That is, he is the client and he is the server. I want to establish a client or server, or we can take anything, right? Usually, now all the sensor nodes are the client or server. All the sensor nodes will work like a client and server, either client or server. They are the clients or they are the server. They are going to generate the data, no? They will work like a servers or not? They are going to give the resources to the client. Client is nothing but maybe, I think Yojana, some madam, something, I don't know. What is that? I am not. YUP means? Any doubt you have? Hello? In the chat box, YUP given what is
No, sir. Actually, that means yes, sir.
Oh, yes. Right. Okay, no problem. I'm not good in this shortcut. Right. Sorry for that. Right. Now, what we are going to do, we are going to take the broader router, either UDP client or server. Then we are going to establish a connection. If we want to establish a connection, then what we require the slip bridge. We call them as a slip connection request. Means if I want to establish a client server model or a client was server model, we need to have a connection request and connection response need to be done. And then a simple web server we are going to use it, like httpd simple.c file. So first file is a broader router file. The second file is the UDP server that we can use either UDP server or client. The third one is slip bridge, and the fourth one is what is that? HTTP simple. We can also call as COAP. It's an application protocol. This is the file. I request the participants please take this screenshot so that you can do letter case. Even I request the coordinators take this as an assignment if they because they have an exam. No, if they do, if they have exam. If they do this one, you can take. You can consider as one of my parameter. So they can do it if they submit it. It can treat it as an exam also. Okay.
Yes, sir. Sure, sir.
Yes, thank you. Now this is a way of the broader router how we are going to do it. The first step is what we are going to do. We are going to create a new simulation called broader router simulation. What is the name of the file? Is broader router simulation, which we are going to create. Then we are going to create a new simulation, broader router simulation. Now I'm going to ask step by step when I'm doing. So therefore, I request the participants please be serious here to understand the concept. Right? You can learn, but it requires a lot of time. We don't know when we are going to get it because, for example, as a new NEP process has been introduced, and there are so many online courses which you are going to conduct, and because I told you, as a teachers, we need to get updated, otherwise we'll be outdated. Right? We don't know whoever. Suppose, for example, you have attended IoT course in the sense, and the HOD will call you to take the IoT course. Now, if you are neglecting, later you will be feeling a problem. So therefore, I request whenever there is a chance, because anyway, you're putting your effort here. You're wasting your valuable time here by sitting. Now, try to put and try to learn it. That's the only way we can have it. We can learn the things when we have time. Right? After 45, after 55, we don't have time to do it because we have some other problems. Okay. So I request the participants, please be a little bit serious here to learn it. Now, we have a broader router simulation, which you're going to have it. And then, as I already told you, we have 5 windows. This is the network window. This is a simulation control window. This is the nodes window. This is the output window. And then this is the timeline window, which I have, timeline window. Now, what we are going to do, we are going to select the broader router sky mode. The broader router sky mode. Select the broader router sky mode. That's the first step. Step number 1 was not. First, we need to create a broader router. Which we need to create a what we call them as a fog mode first. Fog mode. So for that, what we need to do, we'll go to the modes. We'll go to the add modes, add mode, and select sky mode. There we are going to get the sky mode.sky. Okay. Then what we are going to do, we'll go to the broader router where it will be there in the contigi, it will be there in the examples, it will be there in IPv6. There we are going to choose the broader RPL. Broader RPL. When we select that folder, then in that folder we are going to have a file called broader router.c file. Broader router.c file. Right? We are going to select that broader router.c file. Once we select that broader router.c file, then we are going to select that file and then we are going to compile. We are going to select that file and then we are going to compile. Right? We are going to compile. Now, once we compile it, then we are going to create from C file, broader router.c file, we are going to generate the broader router.sky file. Broader router.sky file, which you are going to create. Do you have any doubt up to this? Okay. Once we select the broader router, the next step is now what we are going to take. We are going to take add the new mode. We have how many broader router is there in our diagram? 1 or 2 broader router. How many broader routers were there? How many broader? 1 broader router, right? One broader router. So therefore, what we are going to take? We are going to take add modes. Once we know that add modes, we have selected 1 broader router and we have clicked it. More relationships, and then add a mode ID. Then IP address, output printf, LED information, radio traffic, attributes, and a radio environment. So once we select that one, now what is the next step is, we need to select the UDP server. We need to select the UDP server. So this is the broader router. And then the sky modes, which we are going to take it as these are these nodes which are going to be connected to the broader. Right? Now these nodes are called as what we need to take UDP server. For that, what we need to do is we need to go to the examples. There is a folder called IPv6. Under this IPv6, there is a folder called RPL. Yesterday I told you what is that RPL? Routing protocol for low power and lossy networks. UDP is the connectionless protocol we have. Connectionless protocol we have. So therefore, what we are going to do, RPL and UDP folder we actually are going to select. RPL and UDP folder is going to select. Once we select that folder, then there is a folder called UDP server. There is a file called udp-server.sky file. Then once we select that file, then you click on compile. You click on compile. Then it will generate udp-server.sky file to udp-server.sky file. udp-server.sky file to udp-server.sky file. Okay. Now what we have created? We have created a broader router. We have created a UDP server file. Now, how many we can create? It depends upon your interest. Now, what we are doing here, we can create 3 to 4 UDP server modes depending upon your requirement. Now, what we are going to do, we'll click on the create button. Then we have selected 4 buttons. This is a broader router we have, and these are the UDP server. UDP server. UDP server. UDP server. UDP server. Right. So we have selected 5 nodes among 5 nodes. One node is for UDP server. Broader router, and remaining 4 nodes are UDP server. Do you have any doubts up to this? You got it, all of you? Okay. Okay, thank you. Now, next step is, now what we are going to do is, now we need to establish a connection. Right? We need to establish a connection, right? A real-time connection, network connection need to be established. For that, go to the tools, click on the tools, click on the serial socket server. Serial socket server. Which one is the broader router? Sky 1, Sky 2, Sky 3, Sky 4, Sky 5. Which one is the broader router among these? Which is node 1 is the Sky node. Very good. Node 1 is the Sky node. Click on the Sky node. Click on the Sky node. Click on the Sky node. Very good. Now, once we click on that, now it will ask listening for the port number. Listening on the port, that port is nothing but a 60001 with modes. It is not sending any type of information. Listening on the port 60001 means it is not connected yet. You have not connected yet, right? Once we know this, then we need to go for how to establish our network to the external internet. That is the next step, right? That's the next step we have. So for that to do is, in order to connect different networks. In our case, what is different network? RPL network is one network, and external network is another network. Now I want to connect to these 2 networks. These 2 networks. Okay. Now, for that, what we need to know, the broader router is used to read the data, route the data between the RPL network and external network. To achieve that, we are going to use the utility called ton slip utility. We are going to use what? A ton slip utility. Now, this ton slip is going to create a bridge, right, between RPL network and the local network. Local machine, your local machine, which your machine will work like a RPL network. For that, what is the file name we are going to take is tunslip.c file. Tunslip6.c file can be found in Contiki 2.7. Right? So this is a way of how you are going to connect it to the different networks. Right? Now to achieve that, we need to open the terminal by pressing Alt-Control-T. To achieve that, we need to open the terminal called Alt-Control-T. Alt Control T. So then you go to the folder called CD Contiki 2.7 tools. Click on that. Then you type this command, make Tunslip 6. If no errors are there, then we are going to run Tunslip 6 is up to date. Tunslip 6 is up to date. We need to run it. Then the next step is here. We need to run this one. To make a connection between RPL network and your local machine, we need to write sudo. I request you take the screenshot of this one. Sudo /Tunslip6 /Tunslip6 -a. The IP address which you are going to give is 127.0.0.1, and then this is the address which you are going to give for ACE:1/64. The whole command we need to give. Okay. Now, once we complete that connection, then you can once you run this command, which we did in the previous step, then you are going to get Tunslip connection with the IP address is going to be used here, transmitting packets and receiving packets. We have not established that yet. Now, what we are going to do, once we know this step, then you can see, once we click on run, there start, then we are going to get server IP addresses. These are the server IP addresses which you are going to get. AAA 212.70401:1:101. So this is the address which you are going to get. Up to this, you got it? You got it, all of you? Yeah. Now, once we know that, now what we need to copy this address. We need to copy this address. And then, if we observe that, now previously it is listening to the port, now it is connected to your internet. Now it is connected to your, means your IoT device is connected to your local machine called internet. Client is connected now. The client is connected /127.0.0.1, and then modes are being transferred. Now we are establishing the internet connection there. Okay. Once we know that the connection is established, then when you press the start button here, the start button, then it is establishing the wireless sensor network can be embedded here. This is the way that IoT devices are connected to the broader router. The broader router is going to be connected to the external network. Now you see, the modes are 156 bytes, and you can see how we can easily start the simulation. Okay, this is the way how we are going to do IoT experiments very effectively. Not only that, we can do a number of experiments which are there in the IoT device. Even you can see whether it is connected or not, your internet connected is not. We can take that IP address which I told, which you need to copy, and you type ping 6, and then when you type that IP address, then you can show that it has been ping command that verifies that it is going to connect it to the internet. That is going to be connected to the internet. Okay. Now we'll try to see hands-on step by step. And later we can show this one. Do you have any doubts here before I go to the hands-on? Please let me know.
No, sir.
Okay. Okay, now we'll take a new simulation here. We'll remove that one, and then what is the name of the file name? What is the name of the file we use? Broader broader router. Right, broader router. Then we can have go for create. Now this is the 5 windows which we got it. Sripad sir, you are doing. Shall I go step by step? You are following me? Yeah. Okay. Now once we get it, then we go first. What is that? We need to go for broader router. Select the broader router. Go to the modes. Go to the add modes. Then go to the create modes, and then go and take the sky mode. Click on the sky mode. Once you click on the sky mode, you got the dialog box. Now you need to select the browse. You need to select the browse. Right? Go back to the examples. Go back to the examples. Select the folder called IPv6. Double click it. Double click it. There is a folder called RPL broader router. Double click it. Then there is a folder called broader router.c file. Broader router.c file. You click on that, open it, and then compile. Then we have created what? Broader router.sky file is created. Then we need to create one file. How many broader routers were there? Only one broader router was there. So create a broader router. This is a broader router which is going to be happening. Right? Now we need to see a radio environment is created. Attribute is created. Now if you want to see how it is going to work, you can go through the mode output. Now you see, this is the sky mode which has been created now. If you see the configuration, this is the sky mode configuration which you can have. You can buy this hardware and you can embed that code into this hardware, and that code into the hardware. Still, it will work. So it will work both simulation based as well as reality based. This is the code. This is the kit which you are going to have. Okay. Now what we will do is, now what is the next step after broader router? Anyone? Anyone? Now after broader router, what is the next step? Selecting the clients. Very good, sir. Selecting the clients. So what we need to do, we'll go again once, means UDP servers, going to the modes, add modes. Right? Now we'll try to take some other modes called Z1 mode. We'll try to take someone called Z1 mode, which you can call it. Now we'll try to see Z1 mode here. Right? Z1 mode we'll try to see. And then we'll go to this one. Go back to the IPv6 once again. There is a RPL UDP folder. There is a RPL UDP folder. Right? Click on the RPL UDP folder. Then we get UDP client and UDP server will be there. We are going to take udp-server.c file. udp-server.c file. Click on the open. Then you do on compile. Then what is that file? It has been created. udp-server.z1 file is created. Okay, once it has been created, then you try to create it. Now we try to create four UDP servers, which is going to send the data to the external. So 4 files is created now. Number 1, number 2, number 3, and number 4. Okay. Now this is a broader router, and these 3 are end nodes which you can have. The end nodes. What is the next step after this client is selected? Broader router with client is selected. What is the next step? What is the next step? Anyone? Establishing the connection. Right? Next step is what? Establishing the connection. Then go to the tools. Go to the tools. Go to the serial socket server. Serial socket server. Go to the tools. Go to the serial socket server. Select the Sky mode, which is a broader router. If you select that Sky node, then it will say listening to the port number. Listening to the port number, it should be open to it. Everyone got you got it? Shall I proceed? Okay. Now we need to go to the next step by pressing Alt Control T. We'll get a terminal. We'll get a terminal. By pressing Alt Control T, we'll get a terminal. Right. Now what we need to do? We need to go for CD space 20 2.7 and tools. Directory we need to select. CD space 20 2.7/tools need to be selected. Then we'll clear it. We are in which directory? 20 2.7 with tools directory we are there. Now what we are going to do? We are going to make tunslip 6, which we want to run tunslip 6 command. Right? Make tunslip 6. Now what it will give? Tunslip 6 is up to 8. Tunslip 6 is up to 8. Okay. Now this is a way of how which we need to establish the connection. Now what we'll do is we'll try to run the code sudo tunslip 6 with the AAA 127.0.0.1 with the AAA which you are going to have it with the 64 which you are going to create. Right? Then you click on that. It will ask the password called, you type on the user. Then you are going to get this information. Tunslip is connected. Now still if you want to see it is connected or not, you can check it. Now it is connected or not. It is connected. Right? Tunslip 6 is connected. Once it is connected now our main step is once we are connected, now we need to run start button. Now you see the modes and the bytes which are sending, which you are going to have. Now if you see, now this is the address which has been generated just now, which you can see very simply. Because started broader router process, the web server is already started with the address is AAA1 and got the configured message from type B and and this is the address which will be generated. Now copy this one, press on Alt Control T one more time, and then you type ping 6 and paste it. Whether it is connected or not, we need to check it out and see. Yeah, it is connected to the network. The IP address which has been generated, it is connected to the network. Okay. Once it is connected to the network, now we can see it here. Then copy it the same address, and then go to the application. Go to the Firefox web browser. You can go to the Firefox web browser, which you would have it, and then in the square brackets, you paste that one. Paste, which we have. It's saying as a Contiki arc. Once we connect it, because it will show the neighbors and roots, the neighbors and roots will be displayed. You got it, all of you? You got it? Any doubts do you have? You can do the experiments of the same category, n number of experiments you can easily do, and you can have it through the IoT devices. Right? Now, this is the way how we can work it out on that. Only you can do by practicing only. We can have with the IoT devices. Let me see one small example how we can see the values in the picture. We can have it. I'll stop the presentation, then I'll go to the PPT. Now, if you see here, a little bit interesting part is there, how we are going to display the sensor readings on COAP through broader. That is the next step which you can have. Now, to achieve this, what we are going to do is, in the same step, we'll take the new simulation, right? The next one is the broader RPL broader router, which you're going to have it. Then we will take the Sky mode, and then we'll type the broader router.c, which we did previously, and then broader router.sky file is generated. Then we going to take one node, and one node is created here. It appears in the network window. That's the first step, right? The second step is now again you take add modes. Then we go for to the browse. There is a call Sky WebSense. Now we need to change the Sky WebSense. You need to select. Now once you select the Sky WebSense, then there is a folder, a file called skywebsense.c file will be there. If you want to do any research work, you need to modify this code actually, right, in reality. So that file will be there, and then we are going to compile that one. We select 3 nodes, add modes, and then 3 modes have been selected with one broader router. This is one broader router we have. This is the one broader router we have, and these are 3 Sky modes were there. Right now, we go for again, go to the tools, and we select the serial socket server, and then we are listening to the port which is going to happen. You press on the you press on this one. Broader router, make it connected to the Puja, right? And then which you are going to connect, which it will ask the password, and then it will you are going to get this one, and then when you press the start button, you are going to get the IP addresses which we did previously, the same steps which we did it, and then we got the neighbor nodes and root nodes. We'll get the neighbor nodes as well as the root nodes. Now what we are going to do, we are going to select now. We are going to select now, like this one, we can select this one or this one. Now, once we select this AA 212-7403-3303-128 and you place in the Kontiki, you will get the current readings from the sensors like temperature, light is 80 and temperature is 24 degrees Celsius, which you will. Hence, we can see our readings in the web server. And even it is possible to store in the cloud also. It's also possible to store in the cloud. This is a way where we can do a lot of experiments in the Kontiki as well as the Puja for IoT, where the students can work it out on that. If they are really interested, they can buy the hardware and they can do it. Right? This is from my side. If the faculty have any doubts, please.
If anyone having doubt, kindly ask. No doubt, sir.
Okay, madam. If faculty have no, yeah.
Sir, there is one question.
Yeah, yes. One question regarding network connection for what, sir?
One question regarding network connection for LoRaWAN.
Oh, LoRaWAN. You want to connect it to LoRaWAN? I mean, you already which platform you are using? So, which platform you are using? In Kontiki, you mean to say? Yeah, you can have it. There is a one. Let me show you. One thing is there, like Kontiki next generation. You can use it. It is possible to go for that one. Kontiki next generation. This is the next generation Kontiki, which is for IoT devices. Explicitly for the IoT devices, you can get. You can work it out on that. So there is a lot of network visualization table will be available for it. You can go through this one also. Right, how it is going to be connected, all these things will be known to you. Kontiki for next generation for the IoT. You can have an extension. I told you only basic model, but there is a next generation for the IoT devices. But there's there you can work it out. There is a manual is there how to connect to the LoRaWAN. We can have it, but LoRaWAN code you need to have it.
So, Sarangi sir is asking about the hardware compatibility.
Right, in Kontiki, hardware compatibility that you need to take care, sir, because there is interoperability issues there, compatibility is there, but the universal advantage is there because you are going to do in embedded seats, sir. So the compatibility is going to be supported.
Okay, sir.
Okay, madam, that's it from my side. I thank personally the coordinators, head of the department, and all the participants for giving me the opportunity to share my knowledge to all the participants. That's it from my side. I thank one personally, one and all. Thank you very much.
Thank you very much, sir, for such a knowledgeable session on Kontuki and Puja Network Simulator. It gave us practical insights actually, and I'm sure your session will be useful for all the participants. And so, on behalf of A.G. Patil Institute of Technology, I thank you for sharing your valuable time with us from your busy schedule. Thank you very much, sir.
Thank you, madam. Thank you very much.
Okay, dear participants, we will take a 1 hour break now, and the next session will start at 1 p.m. So we'll meet and gather at 1 p.m. again. Thank you.